A Punnett square is a table in which all of the possible outcomes for a genetic cross between two individuals with known genotypes are given. Pretty much, it allows you to predict the frequency of genotypes and phenotypes of offspring when you know the parents' genotypes. For example, let's say capital B is the dominant brown-eyed allele and lowercase b is the recessive blue-eyed allele. Let's also say that a brown-eyed individual with the genotype capital B lowercase b is crossed with a blue-eyed individual with the genotype lowercase b. The brown-eyed individual passes both the dominant and recessive allele, while the blue-eyed individual passes two recessive alleles. The genotypes of the offspring are shown in the first Punnett square, and the phenotypes of the offspring are shown in the second Punnett square. Continuing with the same example, if a heterozygous brown-eyed individual crossed with a homozygous recessive blue-eyed individual, approximately 50% of the offspring will have brown eyes, and the other 50% will have blue eyes. In this example, let's say a brown-eyed individual with the genotype capital B is crossed with a blue-eyed individual with the genotype lowercase b. The brown-eyed individual passes two dominant alleles while the blue-eyed individual passes two recessive alleles. The genotypes of the offspring are shown in the first Punnett square, and the phenotypes of the offspring are shown in the second Punnett square. Continuing with the same example, if a homozygous dominant brown-eyed individual crossed with a homozygous recessive blue-eyed individual, 100% of the offspring will have brown eyes. Let's say we had an individual with brown eyes. How would we know if they are homozygous, dominant, or heterozygous? In other words, how do we know if their genotype is capital B, or capital B, lowercase b? The answer is through a test cross. A test cross is a cross between an individual with a known genotype and an individual with an unknown genotype. If we wanted to know the genotype of an individual with brown eyes, we would cross them with an individual with blue eyes, because the individual with blue eyes must have the genotype lowercase b. If the individual is homozygous dominant, then all the offspring will have brown eyes when crossed with an individual with blue eyes. If the individual is heterozygous, then approximately half of the offspring will have brown eyes when crossed with an individual with blue eyes.